So I started last week and then I ended this week. I hadn't shown this because I wanted to show when I finished all of chapter 3 reading for Mendelson. It's been a long read, longer perhaps than it should be. I think I should have started doing problems earlier, but I wanted to build up a big base from this book. And I don't think I'm going to do many problems. I'm going to do enough to get a good feel for the subject. Chapter 3 has a lot of material that I already I learned some of it in a different way, let's put it this way, in number theory, and that's why I'm showing this book. I already read this whole book, and I've shown it also in my channel, so I'm only mentioning it just to say, you know, number theory. But so a lot of the theory, all the theorems in chapter 3 are really a very interesting foundational way to build all of the integers. The same way as in Rudin chapter 1, there's a construction of the reals. I love the way this book really, even though it says number systems and the foundations of analysis, most analysis books never talk about the integers. Really. I mean, they say a couple of things about integers, but never go deep. And so I'm really glad that I'm reading this book because it really builds, of course, it builds on the piano system for the natural numbers in chapter 2. And then it just keeps going back to it and then adding more layers that come with the integers. Uses relations, equivalence relations, and the proofs build fairly simply, and yeah, it's a very systematic way. Of course, defining rings, and then the difference between a ring and an integral domain is very small. I knew a little bit about rings because I knew that the numbers mod n, mod a prime, are constitute a ring, and so he goes into the properties of all of the rings, these 7 properties. And he keeps going back to these 7 properties. Of course, you can add, you can subtract, you cannot divide. Fields is where you can divide, so you cannot divide in rings. And there's no multiplicative inverse. And then you add a number 8 property, which is really canceling out. So x times y is equal to x times z. X not equal to 0, then y is equal to z. I mean, it's stated in a different way, but I like this way better. And so then you get this whole business where you're going and starting with something that only has addition and multiplication, but then now you want things to be ordered. So there's all these greater than, less than, or equal to, and trichotomy plays a big role. And so the proofs sequentially build up, and you're going through all these axioms for rings. Well, I'm sorry, the axioms for ordered integral domains, and you keep going back to them. So it's been a very long read, and I've really enjoyed it, of course. I mean, I love this stuff. So yeah, all of chapter 3 read. And chapter 4 is shorter, so that should not be as long as chapter 3. Then I'll show my notes. I also will go back to connect this video in the playlist to the last video for Mendelson. That in the last video for Mendelson, I actually never showed that I did complete chapter section 2.5, the latter part of, and 2.6, because back in the piano systems, you start with addition, then you move to multiplication, then you move to exponents, exponentiation. So just going to briefly show, just for the sake of saying, you know, I read all this, took my time reading it carefully. And so, which goes back to the last video where I showed Terence Tao's quote that you start by adding, then you turn it into products, and then those products become exponentials, which I think is really well said. Then if we jump over to the chapter at hand, I'm going to show this, but I already showed the book, so I'm not going to go in, and I'm not going to show every page in careful detail. But yeah, it's been a very thorough read, and after a while, I get into a kind of like a rhythm. I see how it's like there's like 20 or 30 different induction proofs, lots of induction proofs. just to lay out the integers. And again, I don't think this material is in hard. I mean, definitely, I've never seen any of the other books that I have at my disposal. Yeah, I don't think I've seen any of the books that I have at my disposal. So I'm really glad that I'm seeing somebody build the integers in this gory, really gory detail. Absolute values, all the different comparisons for absolute values. Greatest common denominator, and then you get into things that have to do with number theory, and this is really where everything really was made a lot more straightforward for me because of having done number theory before reading this book. That really helped. I mean, the Euclid's proof, which I've seen before. So there's a couple of proofs that were sort of repeats of things that I've seen before, but I really like to see somebody else do a proof in a different way. There's this book by Springer that's like proofs from the book. I wish I had that book. And it does that. It'll have the same theorem being proven by multiple people different ways. So this is sort of a little bit like that. And so even though it was a little bit of a tedious read, if you will, I think I needed it. I needed to see how someone will build the integers. And part of it, of course, part of the constructions have to do with doing the relations for modulo primes, and proving the various theorems from number theory. Yeah, and then a lot of times you're starting off with a piano system that just has addition and multiplication, and the whole business is what do you do when you make it ordered. And so Mendelson keeps going back and forth between just the ones that don't have order yet and the ones that do. Then there's this whole business, this terminology that is used in the book where you take a symbol and you say, well, in this subdomain of my system, I'm going to have addition and multiplication, but I'm going to prove that it's equivalent, which makes perfect sense. And of course, it's detailed in the book. These are just notes from the book. So, for example, you can add, subtract, and multiply in the natural numbers, and you can do it in the integers, even though the natural numbers are a subset of the integers. And so, yeah. So I'm up to this page. I have read, so this notebook has 272 pages. I have done way more reading than it would have been advised. And so I think there's going to be a little bit more of a focus to problems. I didn't do the ratio, the latest, because from 252 pages to 272. But I think I'm still back at like 19% ratio between problems pages and notes pages for the entire project. So I think definitely in the case of Mendelson, I don't plan to read anymore until I do some problems. And that'll be next in the playlist that has to do with Mendelson. It'll be problems.